morning to all of you. Welcome to the free lecture series on the electrical engineering. Here we are going to discuss the lecture number 4.6, that is called different winding concepts in the stator and the rotor. So this is basically a general introduction of the windings that we have put on the rotor or we have put on the stator. Here we are going to discuss the three important cases. The first case we are taking a three-phase balanced winding which is put on the rotor and a simple two windings which is placed on the stator. So here we have seen that this is basically the stator, which is called the stator, and this is the rotor winding. In the rotor, there is a three-phase windings are placed where we can say that this is called A, this is we are calling as A dash. Similarly, this is called B, this is called as a B dash, this is called C, it is called as a C dash. It is a two-pole machine where the number of poles in the stator is 2, and similarly automatically the number of poles generated in the rotor is also 2. Otherwise there will be no torque generation. So it's our mandatory condition is that number of poles on the stator is 2 and number of poles on the rotor is 2. But the rotor is having a three-phase balanced winding which is placed like this fashion. So we can say that this is making an angle A and B and C, making a phase sequence of A, B, C. This is the phase sequence. Here, as the number of poles is 2 in the rotor and the stator, so we can say that theta electrical equals to 2 by 2 times of theta mechanical. So theta electrical equals to theta mechanical, because number of poles on the stator and rotor is same. So this is angle basically represents as a theta electrical, which is basically about theta electrical equals to 120 degree. Let us take, this is the zero reference point. This is the starting point where we are assuming theta e equals to 0, and up to this point we can just remove it for the sake of explanation. From this side to this point, if it is distance is equal to 0, from this angle to this angle, this is called theta e. So if we taking as a reference vector, as a reference which is at an angle theta e, then we can come to a conclusion that EA is equals to basically EM sin theta e. EB is equals to, we can say that EM sin theta e minus 120. Because its A is having a theta e reference, then B is left behind by an angle of minus 120. Similarly, with reference A, the C left behind by an angle of minus 240. This is angle minus 240, this is angle minus 120. So EC equals to EM sin theta e minus 240 or plus 120. So the electrical angle between A and B is basically theta e minus 120 degree, like this fashion that we have discussed. If we draw the concept of this in this section, if you cut this section like this fashion, under the influence of north, there are three conductors A, C dash and B dash. Under the influence of north, there are three conductors are coming like this fashion. This is the influence of north and this is the influence of basically the south. Influence of north and influence of south. This is B theta. Under the influence of north, the conductors are coming like this A, this is C dash, this is conductor 1, 2, 3. Similarly, at 1, 2, 3. In this influence, the conductor coming is A, this is C dash, and this is B. Similarly, at this influence, conductor B dash, this is C, this is B dash. If we draw the angle, we can say that this having a theta e angle with respect to 0 degree axis, and this is basically we can call as up to this point which is theta e plus phi. Similarly, the difference between A and A dash basically the pi. This pi is called as electrical angle, where A and A dash are being electrically apart from each other with an angle of 180 degree, 180 degree electric. Similarly, B and B dash is having an angle of pi, like expression B and B dash. Similarly, C and C dash is basically electrical angle of. This is the basic concept that I am going to discuss. Then, what is the concept? What is the basic difference between the electrical angle and the mechanical angle, and how the conductors are apart with which angle it's called electrical angle, like this. Now, consider the case 2. Consider the case that the three-phase winding on stator. So, we can circuit. This person, this person, this, this, conductor A, this is conductor B dash, this is conductor B, this is conductor B dash, this is conductor C, this is called B dash, this is B, this is called B dash, this is C, this is called C dash. And if the rotor is containing like this fashion, the rotor is there. This. So here we can say that A and then B, then it is C. This is making an angle of basically 120 degree. This is angle of again 120 is angle of again 120 degree. And from A to A dash it is angle of 180 degree electric. Since here we are assuming that the pole equals to 2, the number of poles in the stator and the rotor is 2, then we can say that the electrical angle is P by 2 times of the mechanical angle. Theta electrical is 2 by 2 of theta mechanical. So we can say theta electrical equals to theta mechanical. This is the basic concept. So it is also the basically theta electrical, this is theta mechanical. Similarly, this A and B, the angle between A and B is theta electrical, which is also theta mechanical. So we can say that this is A, this is B, this is A, this is B. This angle is basically 120, which is equal to theta electrical, equal to theta mechanical. But if the number of poles is changes in the rotor and the stator, then this electrical angle should not be. So that case will be discussed in the case number 3. Consider the case 3. That three-phase winding on stator, but number of poles is full. This is the important. This case is important, and actually this is the conclusion of all the things. Let us draw the basic connection diagram of it. This question. This is one point. This is another point. This is another point. This is so we can just keep marking it. So we are going to determine it. This is A1. This is A1 dash. This is basically A2. This is basically the A2 dash. Similarly, this is called basically the B1. This is B1 dash. This is we can called as a B1. This is called B1 dash. This is called as a B2. This is basically the B2 dash. You can see that this is B1. This is B1 dash. This is B2. This is B2 dash. Similarly, we can consider the case. This is A1, B1. This is basically the C1. This is C1 dash, and this is C2, and this is basically the C2 dash. You can say that this is C1, this is C1 dash, this is C2, and C2 dash. Let's join this to make a four-pole state. Here we are making a four-pole state. This is basically four-pole state. So this is basically a four-pole stator where we are using the winding like A, B, and C. Similarly, this is A1, A2, B2, and C. Just name it. This is A1, this is A1 dash, this is B1, this is B1 dash, this is C1, C1 dash, this is B2, B2 dash, this is B2, B2 dash, C2 dash. In the previous case, we are just taking the only three-phase winding A, B, and C, the complementary operator. That is, we are taking the A dash, B dash, and C dash, A dash, B dash, C dash. This will give say two-pole machine. Similarly, if we are just adding the another winding, it gives another two-pole machine. So basically, this stator is having a four-pole machine. But just by adding the two three-phase windings in the stator winding, we are converting the two-pole machine into the four-pole machine. As a result, the rotor is also consisting of a four-pole machine. That's as I already discussed in the lecture number 4.1, in order to generate a uniform torque in the induction motor or any kind of the machine, we have to be considered the number of poles in the stator and in the rotor should be same. So here in the stator winding, by adding the additional three-phase coil, we are just converting to the two-pole machine to the four-pole machine. So the rotor is also having a four-pole machine. So draw it in this fashion. This is basically considered this. This is the center of it. This fashion. This is this. can say that the N1, suppose the 4-pole machine, this is N1, this is the S1, this is the N2, and this is going to be S2. Here we can closely examine that in this section we have seen that the A1 is having the complementary A dash like this fashion, making an angle of 90 degree. Similarly, A1, B1, C1 making a phase sequence. Similarly, A2, B2, C2 making a phase sequence. So here we can see that mechanically the angle between the A1 and A1 dash is 90 degree, and the angle between the A1 and B1 is basically something like 60 degree. This is the angle between A1 and B1. This is basically going to be like 60 degree. So we can say that mechanical theta m equals to basically 90 degree between A1 and A1 dash. Theta m is equals to 60 degree between A1 and B1, basically like this. In the previous case, we have seen that the angle between the A and A dash is basically 180 degree, and the angle between A and B is basically 120 degree. But in this case, we have seen that the angle between A1 and B1 is 60 degree, and A1 and A1 dash is basically 90 degree. But in order to maintain a phase sequence of minus 120, which basically what is the significance of it? That means here we are taking a theta electrical should be equals to P by 2 times of the theta mechanical. Theta electrical equals to 8 to 4 by 2 times theta mechanical. So we can say that theta electrical equals to 2 times of the theta mechanical. If we are considering the case 1, we can say that theta electrical equals to 2 times of the 90 should be 180 degree of the between A1 and A1 dash. Similarly, for this theta electrical equals to 2 into 60 equals to 120 degree between A1 and B. So that means electrically the angle between the A1 and B1 is 120 degree, but mechanically, physically, we can say that the angle between the A1 and B1 is basically 60 degree. Similarly, angle between mechanically the angle between the A1 and the A1 dash is 90 degree, but electrical angle is going to be like 180 degree. So this is the difference between the electrical angle and the mechanical angle. And electrical angle is always be considered. So we can say that the three cases like this fashion. This is basically the A, B, and C. This is plus minus E1. This is plus minus E2. This is plus minus E3. Okay. We can just take for this the sake of expression like this is a plus minus E angle 0. This is plus minus E angle minus 120 minus, it should be plus minus E angle minus 240 minus, this is basically A1, this is A1 dash, this is B1, this is B1 dash, this is C1, this is C1 dash. Now consider the angle between A dash, we can say that A2, B2 and C2. Here we can say that this is basically the A2, this is basically the A2 dash. The angle between the A2 and A2 dash is 90 degrees, mechanical angle, but electrically the angle between the A2 and the A2 dash is basically 180 degree. Similarly, the angle between the A2 and B2 is 60 degree mechanical, but it should be 120 degree electrical angle. So here we can say that this. This is V2, V2 dash, V2, V2 dash, C2, G2 dash. This is plus minus E angle 0. This is plus minus E angle minus 120. Plus minus E angle minus 240. So we have understand that the stator is having a three-phase windings, a three-phase winding which is able to making a four-pole machine in the stator. Alternatively, the four-pole stator rotor will be there. So we can see that electrical angle is going to be something different from the mechanical angle, and we are considering in the expression as electrical angle. So A and A dash is having a mechanical angle of 90 degree, but electrically it is 180 degree apart. Similarly, A1 and B1 is basically 60 degree apart mechanically, but practically it's an electrical angle of 120 degree. This is the connection. So another advantages of this kind of the winding is that we can make the series or the parallel combination of system. Here in the A phase, basically we are having this is called basically the A phase. This is the A phase. This is basically you can say that the B phase. This is we are taking as C phase. By making a series of the parallel combination of it, we can strengthen the current rating or the voltage rating of this stator winding. How we can do this? We can easily consider. If we are just adding this winding, series connection winding. Let us suppose if we are just adding this winding, this is A phase A, this is phase B, this is phase C. This is we can say that E angle 0, this is E angle 0 plus this is plus. Similarly, this is E angle minus 120, this is E angle minus 120. Similarly, this is E angle minus 240, this is E angle minus 240. So here we are voltage rating is increases, the current rating is remains constant. So when there is a need of having a high voltage, just by series combination of this connection, we can increase the voltage rating of the stator winding. Here we have shown this is called A1, this is called A1 dash. Similarly, this is called A2, this is called A2 dash. Similarly, on the question. In the parallel combination, we can connect this winding in the parallel phase like this. This is A, this is like this A, similarly like this A, B, and B2 dash. Similarly like this is C1, C2, and corresponding dashes. So like we can say that E angle 0, E angle 0, E angle minus 120, and E angle minus 240. Here the current is going to be divided, so the current rating is going to be increases. So in this connection, by using the parallel combination of the phase windings, we can connect this. The current rating is going to be increases, and the voltage remains constant. So as per our requirement, as per our need, as per the load requirement, we can connect the stator winding in the series connection or in the parallel connection. With the help of this connection, we can strengthen the current rating or the voltage rating of the stator connected windings. So how we can connect them? Let's draw it for series connection. The circuit is like expression for series connection. This is for phase A. Similarly, this is for phase B. Similarly, this is basically for phase C. This is plus minus, this is plus minus, this is plus minus, this is plus minus, plus minus, this is plus minus, this is E angle 0, this is E angle 0, this is E angle minus 130, this is E 130, this is E angle minus 240, this is E. Here the windings are connected in series, so it's having the current remains constant, but voltage is increases. And now the parallel connection. This is plus minus. This is plus minus. This is plus minus. Here the current rating is increases and the voltage remains. So this is the advantages of the number of three-phase winding. If you are increasing in the stator side, then there is a definitely change in the electrical angle and the mechanical angle. But the advantages is that we can connect the windings in the series connection or in the parallel connection. As a result, the current rating increases or maybe the voltage rating increases. So this is the basic connection diagram of the different winding connection in the stator and the rotor. But we have to think that understand that the number of poles in the stator and in the rotor must be equal. If the number of poles is minimum 2, then electrical angle and mechanical angle should be equal. But if the number of poles is greater than 2, 4, 6 or 8, then there should be a change in the electrical angle and the mechanical angle that we already understand. So I think you will enjoy this session. Thank you very much. In the next session, we will discuss about the concentrating winding